This is my DIY CNC machine. It's pretty good, but could it be improved?
Oh, here we go.
What? Welcome back to the workshop. So in this video series I'm building a CNC stall detection system, so hopefully I don't break any more end mills. So in the previous videos I built a proof of concept circuit, did lots of tuning and investigation and finally got something that kind of works. Then I made some upgrades. I switched over to the ESP32 processor from the Arduino Uno. Then I built some small circuits to clean up the inputs from the sensors that go into the microprocessor. Then I designed a custom PCB board and the boards have arrived, so I think it's about time we got soldering.
Oh, you bastard.
So I made a start by soldering on the headers. So that'll allow me to test out the display and the microprocessor to see if I've made any errors. And it's about time I upgraded this solder station. These little hands-free things are okay, but it's a bit fiddly turning the board over each time and there's not enough light. So we need to do something about that as well. Okay, I've already ran into my first problem. As you can see on this side, these pins, they have a gap in there because you have this row and then that spacing is not a whole pin. So on my board I've just got them all laid out like that, and when I've just put that long header block like that on there, they wouldn't fit and it was almost going to bend the pins. Yeah, it was like that. So I only need the enable pin on here, the rest aren't used, so I've put that one in for now, and then we'll just get, what I might end up doing is taking all these out except the pin I want and hope that last pin will just bend into the hole. Okay, what I decided to do in the end was put them on two separate headers. So we got the one there with all the pins in, which are nice and straight, and then a bit of an angle on that one. Yeah, just put that off to a bit of an angle there, so that will pick up the remaining pins. We don't need those, so that'll work for now. It's a bit of our prototype board. We'll see what else is wrong with it as we go forward. So that wasn't a good start, but I think we can make it work. And then I've also soldered in the support. That doesn't do anything electrically, so I'm going to 3D print a little piece that will go in there. We'll just hold the board this end, because you can see when you start pushing these buttons, yeah, it's cantilevered off there, so it'll give a bit of support. Yeah, plenty of space. Right, so in theory, if I put a USB lead in there, connect that to a USB power supply, it should come on, and the screen should come on, and it should start running the code. Obviously there's no inputs and outputs, but I think we'll check that first. Right, so on this bench power supply, it's actually got a little USB outlet there at 5 volts, so we don't need to worry about that, although it's still on 5. Alright, 3, 2, 1. Oh! Something flashed. Is it in permanent reset? No. Maybe. Okay. Alright, what's going on? Alright, if we go from ground to 3.3, 3.3, yes. V in should be 5. Now I haven't got the components in to get that 5 volt working all the way back to here, but I think if we reference from that point to ground, yeah, we've got 5 volts, so I think that's working, and the little LED's on, so maybe it's something on the display that I've messed up. Okay, after looking at the board, looking at the wiring diagram and checking some pin outs, yeah, I'd made a mistake. I'd swapped the enable and the reset lines over and managed to offset them by 1 as well. So it was pretty wrong. I don't know how I did that, but anyway, that's where we're at. We're working again, so we've got the system down here. So enable, if I go on enable on the screen, should be on pin 5, which you probably can't see from there, but is there. and reset is on 18, which is next to it. Okay. Now in doing that I need to reconfigure the pins, so I need to remap which GPIO pin I use for each of those. So I'll just hook it up to the computer, reflash that code in, and hopefully it will work. Right, so the computer is plugged in via an extension cable on the other side of the workshop. I haven't got the control system or the inverter on, just in case there's any noise coming down that and getting into the microprocessor, because I don't want to ruin it, because it's the last one I've got. We've got the code loaded up there, and I've swapped the definition for the 2 pins, so hopefully you can plug this in and then download the code and it will work. Okay, at least it's not upset, but now we need to go and find that board, which is on COM10. Okay, and then upload it. Okay, we're back in business. Right, let's carry on with the build. I'm just doing all the small components next. So we've got our little resistors there, little 1Ks. You probably can't see them, but they're loose at the moment with the legs bent out. And then we've got our little diode, little Schottky diode, and we're just going to check. It is brand new, but just check. 0.2, pretty low. Nothing that way, yeah, okay. Make sure I get it the right way around. Okay, so this is the little diode that's just for reverse polarity protection. So although I've been running it off the USB to flash the software and just give it a test, ultimately it'll run off the 5 volts there. And then just make sure you don't get that flip the wrong way around. And then there's a little regulator on there, I think it's that one, that drops that down to the 3.3 that some of the rest of the circuitry uses. One thing to be careful of, well, I've got to be careful of, is not plugging in the USB and the 5 volts here. I don't know what will happen. Perhaps it'd be okay, because they're both 5 volts at the end of the day, but I prefer not to do that. I did think about putting a switch or having a jumper, so that if you're coding it, you put the jumper in one position, and if you're running it off the 5 volt supply inside the electronics cabinet, you take the jumper out or something. But I'm probably not going to flash it that often, so it's just me, so I haven't bothered. Right, so let's get those legs bent a bit and we'll solder all those in. Okay, next up is the opto coupler, and you can see how small they are. I don't even think that will zoom in, so I can see which way around it is. So that 0 there, or that dot in that corner, that is pin 1, so that should be the right way around. If I put my finger in there, look how small that is. Tiny. Okay, we've got a few more components on now. So we've got the power LED down there, the reverse protection diode. I just checked all that out and that works. We've got the VFD filtering system and the opto coupler there, and the LED. I just tested that all works. And then I'm just putting in the e-stop system here. So we've got our transistor that switches the relay, and then a little flyback diode there for protection. And then the relay. So I've used these before on another project, but they're really tiny. Little 5 volt relay. There's the code, if you can read that. And they've got multiple pins out, or multiple terminals. I think, yeah, they've got 3. And then obviously the power at the front there, so really tiny. Obviously the contacts are really small, so a bit limited on current. I don't know how many cycles you get out of them, but in the I've got it running in the solar project and it's still clicking away and still working okay. Right, let's get that little one soldered in and then we can test that bit of the circuit. Okay, so I need to make a small change here. So the relay is running off 5 volts, but the LED, the indicator for that relay to tell you if it's tripped or not, is running off one of the pins from the microcontroller, and this will be a 3.3 volt output now. So I need to adjust that, otherwise this might be a little bit dim, so we'll run that at 220 instead, and then that should be okay, so we'll swap that one out. Okay, just to double check in case the resistor's fallen into the wrong section. Yeah. And then I've realised for my LEDs they're all supposed to be 3mm, but I've run out of those and I've only got 5, so they're all going to be 5. So that's the negative, so that should just go straight to ground. There's our 0. While we're here, we'll check that one. Okay, and that one should come from there. Alright, I find it's always worth double, triple checking anything that you're making for the first time, because who knows what you've done. Negative, yeah. I've just changed the code so in the main loop it triggers the e-stop, so as soon as it runs it should trigger it. Okay, it's just uploading that new code now. Oh, something clicked. Oh, it's clicking it. Relay's not coming on. Can you hear that? Let's put it next to the microphone. Right, I need to find out why the LED is not working. Okay, the reason was pretty simple in the end. So I've got the pin that controls the relay itself, but I forgot to add the pin that runs the monitor LED. So we'll just add that in and hopefully it will trigger the LED when the relay trips. Okay, so added that as, I think it was pin 2. I need to declare that as an output. Off at the start. It's a bit awkward typing. I'm working around the tripod. Alright, so the only thing left to do is make sure we turn the pin on. It's here. Okay, uploading. Still not working. Maybe it wasn't pin 2. Alright, I just spotted the error. Yeah, I'm sure you're all shouting at your screen. So I just copy pasted that, didn't I? Might help if I actually send that high. Let's upload that. Hey. Oh, of course it's staying on all the time, isn't it? Right, nearly forgot to put the pin low again, and then we'll obviously have to pause, otherwise it'll go back round and switch it on straight away. So we're uploading that. LEDs on, LEDs off. Oh yes, pin 2 is also the internal LED. Alright, no problem. guess that's a nice double check. Nothing getting warm. No, cold. Okay, so I'll remove that bit of test code there because we don't need that anymore, and we'll carry on with the build. As you can see, I got fed up of that little soldering station that I had before, and I've upgraded to this new stand.
Oh.
So I took my time and soldered each one in place, and then did some continuity checks just to make sure everything's okay. Should have a ground on the infrared sensor, and the rest should be isolated. I also decided to fit one of the little chip carriers there, a little 8-pin one. This is for the op amp, which I'm using as a comparator for handling the infrared sensors. And the reason I went for that, so you can just see those there, is I've got quite a few op amps down here, and it'll give me the opportunity to try different ones. So I've got the old classic 741, currently using this one, TL082 and LM393. Yeah, just to see what they're like. Got that opportunity to swap them out quite easily. Okay, get some space on the desk and we'll put some power on. Okay, I guess while we're here we can take the film off and I'll plug that in. Right, next thing I need to do is get some cables made up with some ferrules on, so we'll go and do that. And I need to add a little bit more functionality to this. I want to add a menu to it, so we can go into that menu and change some of the parameters live rather than having to reflash different code, so we can kind of fine tune the sensitivity of the whole thing. So let me start by getting some cables made up, and then we can start plugging the sensors in. And see what happens. So I'll connect the USB cable. Alright, that's a good start. Okay, just start the spindle and see what happens. Alright, not a great start. Why is that signal not working? Obviously the load meter's gone up because it thinks there's a big speed differential. But no, there isn't. So let's start debugging. Let's see. It's a bit noisy, but yes. I think I've just spotted the problem. Although these are labelled V0 or VO and ACM, they're the other way around on the inverter. So the LED and the optocoupler won't be driven in reverse. Up to a point anyway. Okay, start the spindle. Okay, restopping. Light came on and we got speed. Alright, obviously we've got to change the parameters a little bit, but that worked. A bit faster, they're both going up. And this little LED down here is giving some indication of the speed. It's being fed by the PWM signal, or the pulses anyway, from the inverter. So it should get brighter as we go faster, which it is. Now they are a little bit different. Might be because I'm now running it at 3.3 volts instead of 5, so maybe the pulses are a slightly different shape. I need to change the threshold, probably just to count, you know, what's definitely a high and a low, but that's just tuning. So we've got acceleration. Oh, no deceleration. All right. Okay, I've been playing around with the code and I've added a menu structure. Now in the past I've been playing around with arrays, and the problem with that is you can only store certain variable types. So I'm experimenting with a structured array, and in this one I can store both strings and integers and numbers and so on. and have it more generic, so you've got like a big array of the whole menu, and then when you use the keypad and go into the menu and just index up and down, you're basically jumping through rows of the arrays, and then the columns contain whatever you want, like the text value, the min max values that's allowed to be, the step, so when you press add and you want to increment it, how much do you want to add, like 1 or 5, what's the minimum maximum, so you don't go any further, things like that. And the nice, well, I've also got a variable that looks at the size of that array, so if you just add some more content, you know, you want to add a bit more later, just add a few more rows into that array, and then it accounts for that, and it knows how big it is, and it basically automates the displaying, handling, and the control of all the variables in that array. So it's a little bit generic, so it'll just print the label, the value that's currently stored. It's going to say just for now what the increment and decrement is, the values for that, how much it will go up and down by, what's the max and min. Obviously once it's finally implemented we won't see that, it's kind of behind the scenes. So everything's in this structured array, which makes it a lot neater. So if I increment the value of the menu pointer just by pressing a button, it will jump to the next line of the array and it will print the next value, the next label, and then when you press the up and down to actually change that value on the front panel, it will just add whatever's in the increment or decrement value, as long as you're within the min-max values. You know, those are the upper and lower bounds. So it's all a little bit automated. So you only got to index this number here, and then when you want to change the value in there, it just looks up this value here and it adds it. So all these button presses down here, that's all they're doing. So the menu bit of code is actually quite short and quite generic. And because I'm using a structured array, I can add fields on later, and it'll just be, you know, dot something else, and you know, I haven't got to rewrite the code. I'll bring you in close and you can see how it works, and also I've made a slight change to the load meter as well, so that's a little bit more intuitive. So let me give you a quick demo of what it does now. So has it worked? So the menu was on select. Alright, we're in the menu, so we're showing variable 1. Obviously this is a bit of a test. That's the actual value, that's how much it'll add or subtract when I go up and down, that's the min and max. So we should, if we do add, make sure you can still see it. It's going up in ones, or it can go down in ones. This might be some kind of acceleration rate, threshold, percentage load, whatever, you know, as many variables as we want. Okay, so we can hopefully go all the way up to 50. Yeah, and then all the way down to 0. Oh, did that? Oh yeah, okay, so it doesn't clear the screen, so that's a residual 0. Okay, that's fine. Just check that by going up. Yeah, okay, yeah. It's obviously got 2 digits there and it's pushed it across. Alright, that seems to work. Now we should be able to go across the variable 2 and play around with those values. Variable 3, 4 I think was the maximum I've put so far. Oh, and it goes back round to 1. Alright, and it's remembered the values. Now I don't think I've put an exit from this. Did I do that? No, I didn't. No, I haven't done that. Right, so we'll add that next. I'll think about what variables I might want to control. I'll add those in here. I'll keep those on the screen for now because it might help debugging, but ultimately they'll go and you'll just have the actual variable itself. Right, again, yeah, that went pretty well, working as expected. So, progress. Okay, I've just added some more parameters to the menu, so let's have a look in there. So I've got how many averages. We've currently got that on 10. We'll have to play around with that in a minute. And RPM threshold, so this is if the actual RPM falls below 70% of the demand. So if the spindle, you know, is falling away, then it'll do a few other checks, but it's one of the things that says, yeah, I'm probably stalling. This is scaling for the VFD RPM, so just to get the reading exactly matching what's on the inverter, because the pulses that come in, they rise up within a certain time frame and then they come back down again, so the actual length of that pulse may not be 100% correct, so it's got a little bit of scaling to get that fine-tuned. And what else have I got? Oh, I haven't done variable 4. Right, so if you remember, there's a lot of hysteresis on the speed before, wasn't there, with 10 averages, so let's bump that down, let's say 4. and then we'll start the spin. Oh, to come out of the menu, don't we? I know these screens don't show up that well on the camera, but the spindle speed's here, which is the actual speed. The speed demand from the VFD is here, and then this load meter will fill up here, and the stars represent the kind of maximum threshold. So if you go into that load zone, and there's a little counter as well, so if you go into there and stay in there too long, I'm talking like milliseconds, then it triggers the e-stop, and then you got some indication of the run condition. So it kind of works okay at the moment. There are some things that aren't working as I want. We'll show you those in a minute, but first of all, let's take you through that. So if we just start the spindle, just ramp it up a bit. That's one of the things I've been noticing. You see that they're different, so let me go and tune that. So we should be at about 4,000. Yeah, okay. This is the comparison or reference voltage for the op amp. Right, let me show you where I've got to so far. I think I still need to do some tuning, maybe some tweaks to the software, but it does this so far. So we're running at 4,000 on the inverter, and yeah, we're 4,000 here, and we're just under, so I might need to do a little bit of tuning on the either on the pot or more likely in the software. And then the load meter, or it's really an RPM follow error like on a servo. So if your follow error is too big, the bars will grow, and if they get to the stars and stay in there for a few milliseconds, then it'll e-stop. And these parameters are tunable. So if we just, well, first thing I'll do, I'll just switch it off, and you'll see there's a bit of spool down time. Because there's this moving average and it's smoothing the values, there's a bit of a rundown time there, which might be too high. Let's just go back up again. Yeah, you see, and because of that spool down time or accumulated error, yeah, so because of that, sometimes you trigger an e-stop. So in fact, let's go in there now. We'll go into the menu. Just switch that off for a minute, so I can just change the number of averages, or we can, so let's just try 2, that'll be hardly any at all obviously, and we'll come out of there. Now it should, oh, let's just run that, and now it'll track really quickly, but it might have a few spikes in it because we're not averaging. It's still taking a while to spool down, there's something else going on. Alright, more debugging to do. Let me show you the other features then. So also in the menu, go to the next item, the following error. So this means if it gets up to 70% out in the RPM, then it will trigger the e-stop. So let's just show you what happens if I bring that down. Let's say 40%. And you'll look at the display. Now you'll see the stars are quite long, so it won't take much error, 40% error, so it's 10% per bar to get into that zone, so it's much more likely to e-stop. Looks like the, oh, I think we've got a dodgy connection on that, on the spindle. Let me just adjust that again. Or is it on the pot itself? This spindle's stopped working. There's your pot. Alright, that's on the scope. Let's check the raw feed from the sensor. Yep, that's okay. So the output pin 1. Oh, killed something. So it's going in and not coming out. Oh dear. Okay, I'm not sure what happened there, but we lost the counter on there. We weren't getting any output out of the chip, but we were getting an input to it. So I've replaced it with a new one. Maybe I spiked it somehow with the testing, I don't know. Right, let's see if this one works. I'll switch it on. No. So pin 1 is our output, which wasn't working on the other chip. Yeah, nothing on the scope. Pin 2 is our reference. That should have a DC value in it of whatever that is. Which is... that cursor's at 2.4. Okay, so our reference 2.4 volts. Which might need to go down a little bit, but that's okay. Pin 3 is the signal from the sensor on the spindle. Okay, so that's working okay. That's really nice. That's actually pretty clean just coming in. Oh, okay, what's going on? So I'll finish the video there. Thank you very much for watching. Whoa, hold on, before we roll the credits. Found another problem. It's running a bit inconsistently, sometimes missing pulses, something's going wrong. So been playing with this for a little while. As you can see, I've taken the screen out and taken the microcontroller out, and then I've rigged up a little temporary power supply here. So we've got 5 volts going in, and then across that potentiometer I've also dialed that in to give 3.3. So we've got 5, 3.3 and the ground, so we can test all the logic and all the sensing side of the circuitry down here. And you can see one of the LEDs is glowing. As you can hear, the spindle is running. So I've already swapped out the chip for another one because I thought maybe I'd damaged that, but that doesn't seem to be the case. Let me show you the 2 signals. So I'm going to put it onto pins 2 and 3 of the op amp, which are here. So 2 is the reference voltage, which will be, well, I'll tell you which colour that is in a minute, and then our probe from the infrared sensor will be the other one. So basically we're looking for when the pulse goes above that reference voltage, and when it goes below, make sure that's okay. We'll have a look at those signals. Right, okay, it's a bit awkward to get these on, so we'll put that on pin 3. So there's our pulses coming back from the sensor, and that cursor there is 5 volts, so we're getting basically between 0 and 5, so that looks okay. Sensor's working alright. We were getting 0 on the display, so something wasn't getting back to the controller. And then the threshold is this one, which is the blue, which is a bit low, but doesn't really matter. So that's where it's triggering, so that looks okay. And then the output that's going to the microcontroller is then going to be on pin 1, which is now blue. Ooh, that looks a bit low. Is that the problem? Let's bring that down. So I think the logic on the pin, so if it's 3.3 total, then it's going to be about 1.6. Let's put this at 1.6, which is going to be the threshold for whether it's a high or low, I would guess. It's 1.6. Okay, and try it again. So that's what's coming in, and then what's going out. Yeah. Ooh. It's only just getting above the high. Okay, and then back to the reference. So I wonder if that reference needs to be a bit higher, doesn't it? And also, okay, so that blue output voltage is going to be controlled by the rail voltage of the op amp. Now, I was running it at 5 volts, and because of worries about overloading this, I've now dropped it down to 3.3. but it does mean that the output is, because it doesn't go rail to rail, is now lower. Maybe that is the problem. I'll just zoom in a bit more. So let's just look at the trigger. Okay, so the trigger is at 1.6, and then the actual pulse is, oh sorry, yeah, it's this one. And they're only just over it, aren't they? Lot to think about. Right, let's switch that off. So, alright, while I think about that, we'll cut back to the original end credits, and yeah, I'll have a look at this in the meantime, hopefully get it sorted by the next video. So we'll finish the video there. Thank you very much for watching. I hope you've enjoyed. Hold on with the credits. I think I've fixed it. It's probably a dry joint on the circuit board, because I can get all sorts of values just by, there we go, if I hold that down nicely, they both agree. Let's do that. I can run the spindle up. And it works. Right. I'll go and sort out whatever that is. Roll the credits. Alright, are we good to go now? Yeah? Okay. So we'll finish the video there. Thank you very much for watching. I hope you've enjoyed. If you have any comments, feel free to leave those below. If you're interested in following along, the usual thing, just feel free to subscribe. And with that being said, thank you for watching, and see you next time.